Okay, I'm going to be talking about the first few pages of this document, except I'm going to be using interval notation when appropriate. Okay? So we have x squared minus 2x minus 15 is less than or equal to 0. Okay? The first thing you do, according to the chart, is find the critical points. Okay? Critical points. We solve x squared minus 2x minus 15 equals 0. It's factorable. So we have x, two factors of negative 15, that to negative 2, negative 5, positive 3. Okay, that might be different than what I have on the paper, but that's okay. So we have x minus 5 equals 0, x plus 3 equals 0. Add your 5, x equals 5. Subtract your 3, x equals negative 3. So those are my critical points. The next step, step 2 on this paper, is to plot the critical points on the number line, a skeletal number line. So we have negative 3 and we have positive 5. Because of the or equal to, these are going to be closed dots temporarily. And then we also number the regions. Number the regions. Now, what we do next is we test each region. Okay? Region 1. When you're testing your region, you pick a number that is in that region. So in the case of region 1, we cannot use negative 3. We can use negative 3.1, negative 3.2, negative 4, negative 5, negative 6, negative 7, anything over in this area, but normally people choose the next integer value in. So we let x equal negative 4. Well, we use 0 anytime we can, but 0 is not in this region. Okay, so we pick negative 4, which is the first integer in this area, this region. I check to be sure whether or not the inequality runs true in that region. I want to know if negative 4 squared minus 2 times negative 4 minus 15 is really less than or equal to 0 in region 1. That's positive 16, that's 8, that's negative 15, (24 minus 15 is 9. That's false. Okay, next I check region 2. So I will pick a test value in region 2. We could use negative 2.9, we could use 4.9, we could use negative 2, negative 1, 0, 1, 2, 3, 4, 5. No, not 5. Okay? I choose 0 because it's in the region it's easiest to use. So I want to know if 0 squared minus 2 times 0 minus 15 really is less than or equal to 0. 0, 0, negative 15. That's true. Next I will test region 3. For region 3, I can use anything after 5. I could use 5.1, 5.2, or 6, 7, 8, 9, 10, blah, 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 blah. I'll do 6. It's the first integer value in the region. So 6 squared minus 2 times 6, minus 15. I want to know if that's less than or equal to 0. 36 minus 12 minus 15. That's 9. And that's false. 9 is not less than or equal to 0. So what we do now is we shade the true regions. Okay? Region 2 was the only region that came out to be correct. So we shade that region. Okay? So, in interval notation, we're going to shade between negative 3 and 5. Why don't I restart that? In interval notation, we're going to include negative 3. We're going to include the 5. We're going to shade the area that's in between. And we're going to use square brackets because of the closed dots. Now, the description of this region is lower limit, upper limit. Square bracket, square bracket. So that is example 1. Here's example 2, or let's see, another example. Well, we'll do example 2. Okay? Example 2 says x squared minus 169 is greater than 0. Okay? Generally, we solve these by factoring. So the critical points are where x squared minus 169 equals 0. It's a difference of squares, like so. So we have x plus 13 equals 0, x minus 13 equals 0, subtract your 13, subtract your 13, add your 13, add your 13. We have x is equal to negative 13 and x equals 13. And these are going to get open dots because of this sign. Negative 13, 13, open dot, open dot. Region 1, region 2, region 3. So I'm going to see if I can't move the table to keep everything on there. Let's see what happens if I move. Okay, maybe I'll get it all in there. Especially if I pull the table back a little bit. Okay. Little delineation mark there. And I think I'm going to rewrite this so it's a little clearer. So, negative 13, 13, open dot because of the or equal to. I'm sorry, there's no or equal to. Okay? So strict inequality sign, we got negative 13. We have 13. Regions 1, region 2, region 3. Okay, so now we will test. Region 1, let x equal negative 14. Okay, negative 14 is in that region. So I want to know if negative 14 squared minus 169 really is greater than 0. That's 196. And that gives me 27. And that's true. Next, we will test region 2. 0. 0 is squarely in that region. Okay? So I want to know if 0 squared minus 169 really is greater than 0. And that 0 taken away 169 is negative 169. And that's false. Negative number is never greater than 0. That's false. So next, we will test region 3. I propose to let x equal 14. I want to know if 14 squared minus 169 really is greater than 0. That's 196. And that ends up being 27 greater than 0. That's true. So here's what we got when it's all said and done. Negative 13, 13, open dot, region 1, region 2, region 3. Regions 1 and region 3 were both true. In interval notation, we will instead use rounded parentheses to enclose the same region. Because these are disjoint intervals, we have to use two separate intervals for these. So we have negative 13 is the upper limit here. There's no lower limit, so we use negative infinity. Union, 13 is the lower limit here. There is no upper limit, so we use infinity. And I believe that takes care of examples 1 and 2. Okay? I'm going to put another example which is not in your paper. A third example not on paper. Okay? Let's say I have x squared minus (17x) plus 42 is greater than or equal to 0. Okay, critical points. Critical points. That is where x squared minus 17x plus 42 equals 0. And so I want to solve it by factoring. Two factors of positive 42 that the negative 17 are negative 3 and negative 14. Okay, so I have x minus 3 equals 0, and x minus 14 equals 0. Add your 3, x equals 3. Add your 14, x equals 14. So, I'm going to put this a little lower so I can use the Roman numerals to label the regions. So, 3, 14, or equal to means closed dots. Number region 1, region 2, region 3. Okay? Now it's test time. We test the regions. So test. Region 1, let x equal 0 is in this region. 0 is in this region. Okay, so we'll use 0 for that region. So I want to know 0 squared minus 17 times 0 plus 42 really is greater than or equal to 0. 0, 0. This leaves me 42. That's true. 42 is greater than or equal to 0. Next step, region 2. Let x equal. We could use anything after 3, but before 14. We could use 3.1, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, up to 13.9, or 13.99999. Anything after 3, but before 14. Okay, I'll use 4. It's the first number in the region. So I want to know 4 squared minus 17 times 4 plus 42 is greater than or equal to 0. That's 16. That's negative 68. That's 42. I grab my calculator. 16 minus 68 plus 42 gives me negative 10. And that's false. Okay, next I'll try region 3. Let x equal, well, anything after 14 will do, so I'll do 15. I want to know if 15 squared minus 17 times 15 plus 42 is greater than or equal to 0. 225, 255 plus 42 225 minus 255 plus 42 is 12. And that's true. So, we still have 3, we have 14, closed dot, region 1, region 2, region 3. Regions 1 and regions 3 were true. Written in proper interval notation, we still have 3, we have 14. We will shade the numbers that are less than 3 and greater than 14, and we will enclose them with square brackets. In interval notation, 3 is still the upper limit. It's going to get a bracket. There is no lower limit, so we use negative infinity. Infinities always get parentheses. Union, because there's two regions. 14 is the lower limit here. There's no upper limit, so we use positive infinity with a parenthesis. I hope that is reasonably clear at this point. I'll stop here.